What's going on, everybody? Boris here at the Ecology Design Studio, bringing you part 3 of this Learn Along series where we try to learn Java together. We're going to take a look at some of the theoretical concepts that we've covered and that we will cover in future episodes. Last time, in the last 2 episodes, we covered 2 programs. The first was a simple addition calculator, and the second used counter-controlled repetition to control the number of times a user could input numbers into the program. And that last program was for fuel purchases. It took the last 10 fuel purchases from a customer or from a user, added them, displayed the sum, and it displayed the average. So what we're going to do now is we're going to take a look at some of the concepts we've covered and an example program for post and pre-incrementing variables. Before we do that, I'd like to show you how I increase my font size on this. I'm using Notepad++, and to increase your font size is a little tricky. You have to go to Settings, not Preferences, but Style Configurator. And it's not enough to just change the font size. You have to go here and click Default Style. On first glance, I thought Global Override was going to basically override the style globally. Exactly what it sounds like, but no, actually that took me an embarrassingly long amount of time to figure out. Okay, so we've done this, and let's start on line 1. The 2 forward slashes begin a single line comment versus the forward slash with the 2 stars, the star on the next line, and then to end it, a star and a forward slash. That's a multi-line comment, and you can use this to type instructions for what the code represents or how to use the program. Okay, syntax error. We encountered several syntax errors throughout building our applications and our programs. And what that is when a compiler encounters code that violates Java rules. NetBeans is very good about this because it will tell you on what line you have a problem, and it will give you a hint on what's wrong and what you can do. Sometimes it's very direct and tells you, hey, you're missing your semicolon and you should probably put one there. Keywords like class are always lowercase. We've used that before and we've seen this principle in action, but we've never actually explicitly explained it. All class names begin with a capital letter. Java is case sensitive. We saw that in the first episode where we tried to change the name of the package. We changed the first letter to be capital, and the compiler freaked out because it couldn't find where the files were. It was looking in a package that didn't exist. That's why capitalization matters. A public class declaration must be saved in a file with the same name as the class followed by .java. Thankfully, NetBeans takes care of a lot of these small things for us and adds .java at the end of our files. Methods perform tasks and return information when they complete their tasks. Method main is the start of every Java application and must begin with public static void main string args. We saw in the last program we wrote that we can have 2 files and that only one of them needs to have this main class declaration, and then from this main class we can use a get method to retrieve information from other files. System.out, we've used that quite a lot as well. Now we're going to define it formally. System.out is a standard output object and enables Java to display characters on the command screen. We used several instances of this. System.out.println. I don't believe we've actually used this, but we will in future programs. It simply displays output followed by a new line character to position the cursor on the beginning of the next line. System.out.print displays the cursor on the same line. We've used this one. And system.out.printf. The first argument is a format string that may consist of fixed text and format specifiers. The format specifiers are placeholders for string or numerical values. And we saw that %d is the placeholder for numerical values and %s is the one for string characters. Common classes already in existence can be imported from the Java library. We did this in both of our programs when we imported class scanner to obtain user input. We could have also set it to obtain data from an external hard drive, and in later programs we'll see how to do that. Integers are whole numbers. So far we've only used integers and we haven't dealt with decimals, but we will in the future. Declaring a variable specifies the type and the name of the variable. We used variable declarations, integer or int, space, and then price or the name of the variable we're trying to do. And if we recall, a variable is simply the location of a value within your system's memory. Constructors, we used that in the previous episode. Constructors create an instance of a class. This can also be called creating an object. Set and get methods are a type of data encapsulation. Instead of accessing class member variables directly, you define get methods to access these variables and set methods to modify them. By encapsulating them, you have control over the public interface should you need to change the inner workings of the class later on. A jar file, which we saw when we compiled, and not just compiled, but actually hit the hammer button on NetBeans in our first program and build it, it creates a jar file that can then be distributed to other people. And it stands for Java Archive and combines many files into one. Software developers use .jar files to distribute Java applications or libraries in the form of classes and associated metadata and resources such as text or images. The parentheses after the word main designates this as a method, a building block of our program, if you will. For a Java application with multiple methods, precisely one must be main in the form of public static void main string args. The word void in there, or anytime we use it, means that our program does not return information upon completing its tasks. In later tutorials, we'll create programs that do this. A variable, I believe we mentioned this previously, is a location in your computer's memory where a value can be stored for later use in a program. A scanner allows a program to read data for use in a program. To do this, we have to specify a source, such as an external drive, or, as in our case, for the last two programs we built, user input. Variable types float and double specify real numbers and can have a decimal. We haven't encountered those so far, but we will, I believe, in the next episode. If an expression has nested parentheses, like so, the inner set is always evaluated first. Now let's take a look at our logical operators. We have equals, not equals, greater than, less than or equal to, and greater than or equal to. We have not used those yet, but we will. A program unit that houses a method is called a class. A class can then be used to create an instance of the class called an object. This is one of the reasons why Java is also known as an object-oriented programming language. Variables declared in the body of a particular method are known as local variables and can be used only in that method. Declaring instance variables with access modifier private is known as data hiding, and we did this in the second program we wrote. And the second file, not the one with the main class, but the second file had a private class. We had a constructor there, and then the main class referenced that file and retained the name of the owner of the fuel price calculator. Declaring instance variables with access modifier private, data hiding. A string's default value is null. A constructor can initialize an object of a class when the object is created, and constructors can specify parameters but cannot specify return types. To see an example of a constructor, see our last program in episode 2. Now let's take a look at the prefix and postfix increment operators, because we'll be using those from now on, especially in the next program we write. Public class increment, we're declaring our public class. We're declaring a main class here, public static void main string args, and then we're declaring our variable. Integer, we're specifying the type of the variable. Then C, we can call it anything we'd like. For this, we've chosen C, and that's the name of our variable. And now we're going to demonstrate the postfix increment operator. We're assigning the value of 5 to the letter C, and we're using system.out.println. And if we recall, we haven't used this one yet in the previous episodes, but in this case, it's going to put the cursor on a new line. So it's going to skip a line and then print 5. System.out.println C++, like the programming language, is going to post increment 5 by a count of 1. So it's going to print 5, and then it's going to note that it's going to increase it by 1 the next time it's used. System.out.println, it's going to print 6 because here it's been post incremented. Now we're skipping a line with this statement, and if this looks like a lot of typing, just remember we can always copy and paste this. So basically we can copy system.out.println parentheses, and then we can just fill in the information that we need. And this is where pseudocode, which we'll see here in a minute, comes in handy, and also knowing ahead of time what belongs where in our program. Basically having a plan, a guide of what the program is supposed to do and what's supposed to go where. This last part of this program, or this code, demonstrates the prefix increment operator. So again, we're assigning the value of 5 to C, and we're using system.out.println to print the number 5 on a new line. This time though, we're pre-incrementing it. So the system, when it evaluates this line, it's adding 1 immediately, and then it's displaying 5 plus 1, 6. And then we're displaying C. So it's going to print 5, 6, and then 6 again. We're ending our main class, and we're ending our class increment. And the output should look like this because we used println, print line. It's going to move the cursor from here to here. It's going to print 5. It's going to move the cursor to a new line, print 5 again, new line, and then print 6. Because if you remember, we put the plus plus here, and we post incremented our variable. We skipped a line, and then on the new line it's going to print 5. We pre-incremented, so it's going to put 6, and then it's going to put 6 again. If we pre-incremented it and then post-incremented it, it would put 6 and then 7 down here. Okay, back to theory. An algorithm is a procedure for solving a problem in terms of the actions to execute and their order of execution. Pseudocode, which we mentioned previously, helps us plan out our program before we begin writing code. Now imagine for a second you're a teacher at a school, your university, and you want to determine whether a student failed. You want to automate that process. So you create a program, and as you're building the program, you're thinking it out, what I need to do to accomplish this task. And we're literally using the English language to just write out what we need. If the student's grade is greater than or equal to 60, then I want the computer to print the word passed. Else, print failed. And then we're ending our if statement. And this translates into Java programming code, and it helps us get an idea of what we want to accomplish and what goes where. So we know we'll say if variable, in parentheses of course, greater than or equal to 60, print system.out.print passed. Else, print failed. And here's some more examples of pseudocode. I highly recommend you guys take a look at these links. They're in the description. These last two are fantastic guides. They're almost like textbooks, but they're in PDF format, so you can save them, print them, or just read them on your computer. Very convenient. This one has a lot of examples of pseudocode. And before we get into the more complex programs, I think it will be very helpful to take a look at some of the longer, more detailed programs here in plain English language. That way we can get an idea of the concepts we'll encounter using the highly technical jargon of Java. That brings us to the end of this theoretical review, guys. Thanks for watching, and as always, I'll see you next time on our Ecology Designs production. What's going on, everybody? Boris here at your Ecology Design Studio, and I have an idea I want to tell you all about.
What's up, everybody? This is Boris at your Ecology Design Studio. Today we're talking about computers, specifically some of the components that it takes to build a personal computer.